Welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question now from the Pure Mathematics P1 International A-Level Edexcel textbook from chapter 2 on quadratics. This is exercise 2G, question number 7. One of the students has requested me to answer this question, so I'm going to do so. It tells us about function h of x, which is equal to 2x squared plus k plus 4 times x in brackets plus k, and k is a real constant. It says find the discriminant of h of x in terms of k. So the discriminants of part A, the discriminant of a function, discriminant is basically, write that properly, sorry. The discriminant is given by b squared minus 4ac. Okay, so a quadratic equation is of the form ax squared plus bx plus c, and a is a coefficient of x squared, b is a coefficient of x, and c is a constant. So here the coefficient of x squared is 2, and the coefficient of x is k plus 4, and the constant here is k. C is equal to k. Right, so we need to find the discriminant of this function. So it's going to be b squared, which is k, plus 4 squared minus 4 times a, which is 2, times c, which is k. So this is going to be k plus 4 all squared minus 8k. So there's part A done. Find the discriminant of h of x in terms of k. And now for part B, it says hence or otherwise prove that h of x has two distinct real roots for all values of k. Okay, so basically we know that a function has real roots when b squared minus 4ac is greater than 0. That's when it has real distinct roots, when the discriminant is positive. Okay, when it has real roots which are separate or distinct, then b squared minus 4ac is greater than 0. If b squared minus 4ac is equal to 0, then it has repeated roots, the same root twice. When b squared minus 4ac is negative, then it has no real roots. So we've got to prove that this expression, that b squared minus 4ac, which we've worked as k plus 4 squared minus 8k, we have to prove that this is always greater than 0. Okay, so how do we do this? Well, let's just expand. You have k squared plus 8k plus 16. If you square this bracket, square the first term, square the last term, and multiply these together and then double it. So k squared plus 8k plus 16, that's a shortcut of squaring the bracket. If you want to square it the long way, k plus 4 times k plus 4 gives you k squared plus 4k plus another 4k, which is 8k plus 16. And you got minus 8k at the end here. Now what happens here is that 8k and the minus 8k, they become 0. So you have k squared plus 16. So I know that k squared is always greater than 0 or equal to 0. Okay, k squared is always greater than or equal to 0. Yeah, no matter what value of k that you put in here, it's always going to be squared. So if it's a negative value, it's going to become positive when you square it. The lowest it's going to be is when k is 0. Okay, when k is 0, k squared is equal to 0. So the k squared will always be greater than or equal to 0. Therefore, we can say k squared plus 16 is always greater than 0. Okay, because it's going to be basically greater than or equal to 16. Right? Because this is the lowest this can be is 16, so the lowest this can ever be, the lowest this can be is 0, so the lowest this expression can be is going to be 16. So therefore k squared plus 16 is greater than 0. Okay, and this is the discriminant, so we can say as the discriminant is always positive, okay, for all values of k, therefore we can say that it will it will always have, as they asked us in the question, has two distinct real roots for all values of k. So therefore, there are two real distinct roots for all k values. Something like that. Not very good handwriting, but that's basically how you can prove that this has two distinct real roots. Okay, you end up with an expression for the discriminant that can never ever be, equal to 0 or less than 0. Always going to be more than 0. Okay, so this is how you prove that statement. Okay, so there we have the answer to this question. I hope that was clear. Students who asked it and anyone else who might have benefited from this, I hope you understood properly. Thank you for watching. Other questions from this chapter 2 from the textbook that I have answered after being asked will be found in the playlist that is going to appear over here. And other questions from this topic of quadratics in P1 can be found in this playlist that should appear somewhere in this area. You can subscribe to my channel by clicking on the link. Thank you for watching and see you soon.